Good morning, everybody. We are going to continue our videos on circles, and we've talked about secant and tangent lines, how they intersect and the side lengths for those, but now we're going to talk mainly about tangent lines and how they work in circles. So we're got a couple notes and examples here. A tangent line intersects a circle at exactly 1 point. Now you should know that a tangent intersects at 1 point. Okay, that is the point of tangency. So point A would be the point of tangency. This part right here would be the point of tangency. Okay, AP is a radius. Okay, and AB is our tangent line. Now you should also remember that a secant line intersects the circle in 2 points. Now a line tangent to a circle, or a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Now we all should know that perpendicular just means it intersects at 90-degree angle, which is right here. Okay. Now some examples that we're going to go through here. We're going to go through numbers 1 and 2. Should make it nice and easy. We need to determine if AB is tangent to circle P. So the way we're going to do that, we're going to go 8 squared plus 15 squared, and does that equal 17 squared? Well, 8 squared is 64, 15 squared is 225, 17 squared is 289, 64 plus 225 is 289. 289 does equal 289, so yes, AB will be perpendicular to circle P, or sorry, tangent to circle P, because it is perpendicular. It fits the Pythagorean theorem. Now if we take a look at letter B, I know then that this is 14, the radius is 11. However, this outside length here is 5, which means this is 11. So the whole thing is 16. So my two sides here, let's see if this is true. 11 squared is 121, 14 squared is 196, and 16 squared is 256. Okay, 121 and 196 would be 317. 317 does not equal 256. So AB is not perpendicular to or tangent to circle P there, because they're not perpendicular. It does not fit the Pythagorean theorem. Okay, let's take a look down at number 5. We're going to move this down just a little bit. Let's look at number 5. Okay, we need to find the value of x. It says if JK is tangent to circle L, find the value of x. So since I know JK is tangent to circle L, I know that is going to be perpendicular right there. Again, this outside length is x, this length is 10. Okay, so what that means then, 10 squared plus 24 squared will equal, I'm going to call it y squared, just to make it easier. Okay, 10 squared is 100. 24 squared is 576. This is equal y squared. 100 plus 576 is 676, which means y will equal the square root of 676, which is 26. Now we're not quite done yet, because I know x plus 10 will equal 26, because we said y is equal to x plus 10. So that means x will equal 16 when I move this 10 over here. Okay, so keep that in mind. If you introduce a variable for another set of variables, you just have to go back and make sure that works out. Okay, if we take a look at number 6, I know LJ is 11. That's a radius, which means LM is also 11. So this whole distance here is 22. So here's where our right angle is going to be. X squared plus 22 squared is going to equal 25 squared. 22 squared is 22 times 22. That's going to be 484. 25 squared is 625. So if I take 625, subtract 484, I'm going to get 141. 141 is not a perfect square, so we do have to take the square root. So it should be 11.87. Now if you use a squiggly equal sign, that does mean approximately. Okay, so that's using the Pythagorean theorem to see if lines are tangent or what the value of x is if it is tangent. Okay, now a couple more properties of tangent lines if we take a look. If two segments from the same external point are tangent to a circle, then they are congruent. So if you look here, AB is tangent to the circle, BC is tangent to the circle. They're both coming from point B, so that means those two lines are congruent. Also, if a polygon is circumscribed around a circle, then all sides are tangent. So I've got a circle and I've got a shape around the circle. That means it's circumscribed. So that means this side will be congruent to this side. These two sides will be congruent. And those two sides will be congruent. We'll do a problem like that in a little bit. Okay. Let's take a look at number 11. Find each value or measure. Assume that segments that appear to be tangent are indeed tangent. So they're both coming from point Q. They look tangent, so I know those are going to be equal. So 14x minus 13 will equal 8x plus 5. There's more x's on the left side, so I'm going to move this one over here. I'm going to move the minus 13 over here. So 6x will equal 18. X will be 3. We need to find PQ. 14 times 3. And we're subtract 13. We'll get 29. So PQ will equal 29. And just for kicks, we're going to plug it in the other one too. 8 times 3 plus 5 is also 29, so that does check out. Okay. Now in number 12, we are going to have to do a little bit of math here. Okay. We know that because ST and SU are equal because they both come from point S. So I know 10x minus 41 is equal to 4x plus 7. I'm going to bring this 4x over here and this 41 over here. 10x minus 4x is 6x. 41, we're going to add it, so 7 plus 41 is 48. X will equal 8. So if x is 8, 10 times 8 minus 41, this length up here is 39, and this is 39. This is also 17. I know that this is perpendicular, so 17 squared plus 39 squared will equal SV squared. 17 squared is 289. 39 squared is 1521. 289 plus 1521 is 1810. If I take the square root of that, I'll get 42.54. And that's the distance we're looking to find. Okay, hopefully I went through that nice and slow for you. Again, we've done problems like this before. Should be nice and quick. We've also done the Pythagorean theorem a whole bunch of times before. Now, my last example for this video, we're going to talk about number 13. Find the perimeter of triangle DEF. Well, we know that if a polygon is circumscribed around a circle, then all sides are tangent. Okay, and if all sides are tangent, that means they are all equal. So if I look at that here, I know this side will be the same as this side, so that's 16. This is 9.5, and this is 11. So if I take all those sides, I know this side is 27. This side is going to be 16 and 9.5, which will be 25.5. And this side is going to be 20.5. So to find the perimeter of that triangle, I'm going to take 27 plus 20.5 plus 25.5. Get your answer there of 73. Okay. Now, we're not quite done with circles. We're going to talk about graphing circles over the next couple days, but you guys should not have any issue with that. We'll talk about it in the next set of videos. I hope you guys all have a wonderful day and stay safe out there.